Hello class, we are here in lesson 17 of unit 6. Alright, our task statement today is the walkathon. Diego, Elena, and Andre participated in a walkathon to raise money for cancer research. Very good cause. Alright, they each walked at a constant rate, but their rates were different. Okay, they weren't all walking at the same speed. So we want to complete the table below to show how far each participant walked during the walkathon. Well, okay, here we got this first row we want to fill in, and all we know is 1 hour, and we don't know anything else. So, well, let's see if we can do a little problem solving and figure things out. So if I look down here, I notice that I have two things. I have 2 hours and 6 miles. Well, okay, if I want to go from 2 to 1, I'm going to divide it by 2, or cut it in half, right? So I'm going to divide this by 2, or cut this in half. So what is half of 6? It is 3. All right, let's make that 2 notches smaller. All right, so it's 3. We know that in 1 hour, Diego walked 3 miles. Okay, so let's go ahead and fill in the rest for Diego. So let's see here. If we make a jump from 6 to 12, then that's going to be times 2, right? Okay, or we can think about it the other way. We can say, well, it's going to be this times 3. Right? This times 3. Either way is a totally fine way to think about it. If we think about it as 6 times 2, then we're going to do 2 times 2, which is going to be 4, right? So we can say for certain it's going to be 4 here, but again, I just want to show you. So if you wanted to say that if we jump from here to here, we're doing times 3, well, 4 times 3 is 12, right? So we can think about it that way, going this way, or we can say this way. 6 times 2 is 12, 2 times 2 is 4. Okay, so then what's that going to mean is going to go in this box here for Diego? Well, we know if we can just do this times 3, it's going to be 5 times 3. That's going to be 15. Okay, so that takes care of Diego. Now, what about for Elena? Elena walked 11 miles, and, well, we happen to know that that was in 4 hours, right? So 11 miles in 4 hours. Okay, so that doesn't go evenly. So let's think about what that means. Well, if we remember with Diego, if it was 12 miles in 4 hours, if we wanted to find out how many miles in 1 hour, we just divided both of these by 4, right? 12 divided by 4 is 3. 4 divided by 4 is 1. So the idea is we're going to, on this row, we're going to divide by 4. So it's going to be 11 divided by 4. Okay, and so let's write that down. 11 divided by 4, what is that if we want to make this mixed number into a fraction? What is 11 over 4? Well, 4 is going to go into 11 twice, right? And then we're going to have 3 left over, 3 out of 4. Okay, if you're not sure how I got that, I can show you in class at some point. But 11 over 4, 4 goes to 11 twice, and then you have 3 left over out of 4. So 2 3/4. So we can say that Elena walked 2 3/4, or you should also be aware 2 3/4 is 2.75. So I'm going to call it 2.75, partly because it's hard to write a mixed number without the proper buttons. But 2.75, 2 3/4, either one's the same thing. All right, and so we know here that, again, if we want to jump from this line to this line, in this case, it involves doubling it, times 2. 1 times 2 is 2, so this times 2. So we need 2.75 times 2. I'll work that out here to show you how that's going to work. 2.75 times 2. All right, 2 times 5, that's 10. So we put a 0 and put a 1 up here. 2 times 7 is 14, plus 1 more is 15. So 5, and then a 1 goes here. 2 times 2 is 4, plus 1 is 5. So is it 550? No. In the problem, we have 2 numbers behind the decimal point here. There's no decimal point in this one here, so it's 2 numbers. So you're going to go 1, 2, boom. It's going to be right there. It's 5.50. So that's what's going to go here. 5.50 or just 5.5 is fine. It's the same thing. Okay, and then for the bottom part here, so once again, let's see, how are we jumping? If we're going to go from 1 to 5, that's times 5, right? So we're going to do 2.75 times 5. So let me just erase part of this here. Oh, it's just the 2, and just our answer down here. All right, and let's go ahead and say that this was 5. Okay, I should probably erase these little marks here. Okay, so 2.75 times 5, well 5 times 5 is 25, so I put a 5. I can have a 2 up here. 5 times 7 is 35, plus 2 is 37. And so that means we need to go ahead and have a 3 go up here. All right, and then 5 times 2 is 10, plus 3 is 13. And again, we check when we multiply how many numbers are behind a decimal point. 1, 2. We're going to go in 1, 2 spots here. 13.75 is going to go here. And that's going to take care of Elena. So then we just need to get Andre. All right, so Andre was 17.5 miles in 5 hours. So let's go ahead and let's jump back to 1, and then we'll just fill in from there. So for 1 hour, we're going to divide by 5. We're going from 5 to 1, so we divide by 5. So we're going to divide this by 5. So let me erase all this here, and let's see what 17.5 divided by 5 is. So for that, we have our little house, 17.5. I got a decimal point here. I need to bring this up here. Divided by 5. Okay, so 5 doesn't go into 1, but it goes into 17 3 times. And then 17 minus 15 is 2. Bring down our 5. And 5 goes into 25 5 times. So 3.5 is how many miles Andre walks in 1 hour. So we can fill that in here. 3.5. All right. And then, as was the case before, we're going from 1 to 2. We are doubling this amount, so we're going to double this amount. It's 3.5 times 2. That's 7. Okay. And then to get to 4, we've got to go from 2 to 4. We double it, right? We double that, so we're going to double this. So 7 doubled. That's 14. All right, so that takes care of our table. Now we're going to answer some questions about all of this. So let's look at number 2. How fast was each participant walking in miles per hour? So miles per hour means you're going to say the miles in 1 hour. So for Diego was going 3 miles per hour. I'm going to call that mph. And then for Elena, how many miles did she go in 1 hour? It was 2.75. 2.75 mph. And Andre, well, we can see here 3.5 mph. All right. How long did it take each participant to walk 1 mile? Well, we would go up here to see what they have per hour, miles per 1 hour. We need to get the mileage down to 1. So that means we need to divide by the number of miles they walked in order to get it down to 1 mile. So it's actually just going to be upside down. If you remember this way, an easier way to think about these fractions here, this is going to be for Diego, it's just going to be 1 over 3. Okay, 1 over 3. For Elena, one way to think about it, if you remember how it was 11 and 4, right? 11 and 4, if we keep it like that, we can just say that she's going to be 4 over 11. Okay, we can think about it that way. All right, and then Andre, okay, you can think about it this way right here. It was 14 over 4. We can change that around to 4 over 14. But we can simplify that, right? 4 over 14, we can divide both by 2. That's really 2 over 7. All right. Now, for the next part here, they ask you to graph the progress of each person in a coordinate plane. And you can use a different color for each participant. So you can use the applet if you'd like. And that will take you to a graph there. You're going to need to take a screenshot of that and add it in. Or we can go to the next page here, and we can graph it like this. Okay, so Now, what I'm going to do is I'm going to show you what the graph looks like rather than taking all the time to do it. I'll just show you, and then we'll go through it quickly here. All right, so you can see here, here is the graph. Let me just zoom in. All right, so you can see here for Andre, Diego, and Elena. You can see here for Elena, she's blue. So in 1 hour, it was a little bit less than 3. And so you can verify that here because, actually, let's go back to the next page. 2.75, it's a little bit less than 3, right? So Diego should be exactly 3, right? Diego is red. Diego's right on 3. 1 hour, 3 miles. And then remember, Andre was 3.5, so you can see the dot is right in between 3 and 4. Here's 2. Here's 4. This has to be 3. And so if you're halfway between 3 and 4, that's 3.5. And you can see the rest here. This is what the points look like while plotted on the graph. You can see time and distance on the y or vertical axis. Okay, so let's look at some more items here. So Diego says that d equals 3t represents his walk, where d is the distance in walk in miles and t is the time in hours. Okay, this is correct. He is correct. They want us to explain why d equals 3t relates the distance Diego walked to the time it took. Well, the idea is that Diego, if you remember, walked 3 miles in 1 hour. So if we were to say, if we were going to put that information in, okay, so 3 miles in 1 hour, if we were to fill in the information for d and t, this is what it's going to look like. If the distance really is 3 miles, that's going to be 3 instead of the d, equals, and then 3, and it's times t here, so I'm going to say that it is times, if it's per hour, this is going to be a 1, and we want to look at this and see, is this true? 3 equals 3 times 1? Well, yes, 3 does equal 3 times 1. So he is correct. Distance is 3 miles, time is 1 hour. If you fill in that equation, it's a true equation, so that works that way, and that's why. So then we want to write equations for Elena and Andre. Well, it's going to be the same idea. Okay, it's the same idea. It's just that Elena, if you remember, was 2.75 miles, and Andre was 3.5. So for Elena's equation, it's going to be so Elena d equals, and not 3t, but 2.75t. And then for Andre, d equals, and it was 3.5t. And so the idea being that if you plugged in those numbers like we did for Diego, you're going to get all of the different values. As the amount of time changes, then they're going to go a further distance, right? Okay, so use the equations we wrote to predict how far each participant will walk at their same rate in 8 hours. So we can use the same equation here. Let's actually go in, let's fill in just for the sake of having convenience here. We'll put Diego's as well. D equals 3t. Okay, so here are the equations. Now, in 8 hours, okay, so the idea is that the time, they're using t for time, is now going to be 8. So in this case here, let's go ahead and we'll just use some space out here. For Diego, it's going to be d equals 3, and now times 8. And 3 times 8 is 24. Okay, and then we come down here for Elena. It's going to be d equals 2.75 times 8. So let's work that out. 2.75 times 8. Guess I can use the same color here. Let's go down here. 2.75 times 8. All right, 8 times 5 is 40. 0, carry 4 here. 8 times 7 is 56, plus 4 is 60. So 0 and then 6. And then 8 times 2 is 16, plus 6 is 22. And it's not going to be 2,200 because we have 2 numbers behind the decimal point. So we're going to go in 1, 2. It's going to be boom right there. So 22. So we can go back into here and we can say that for Elena, it equals 22. And for Andre, d equals 3.5 times 8. So let's see what that is. I should use blue this time. So 3.5 times 8. 8 times 5 is 40. And 8 times 3 is 24, plus 4 is 28. Okay, but it's not 280. In this case, we have one number behind a decimal point, so we're going to go spot in one spot. So it's 28.0, which is the same thing as 28. Okay, so now we have a couple more. We have one more question to go here. So for number 7, for Diego's equation, and the equations we wrote, what is the dependent variable and which is the independent variable? Okay, very simple here. What you're looking for, what are we solving for in the equation? In all of these equations, every one, we were solving for d. We were trying to figure out what the distance was, right? So the distance depended on what happened with the time. If the time changed, then the distance changed. So the equation starts with d equals, so that means that d is the dependent variable, and then t would be independent. D depends on what happens with t. Now, if you rearranged the equation, and it started with t equals something d, then in that case, t would be the dependent variable, and d would be independent. But in this case here, d is independent for these. So I'll just go ahead and write this out here. D is the dependent variable because its value depends on what t is. All right, you can see here as we changed the value of t, it was different, right? T became 8. In the previous table, if the time was something different, like 1 or 2 or 4 or 5, well, then the distance was something different. All right.